Hi everyone, welcome back to my channel. So this is the very first video in my high level design playlist. So this entire series will focus on high level design from an interview perspective, specifically for SDE-2 level. So we will be breaking down real system design problems, okay? And yes, we will be taking a look at how to approach things in an interview. So today we are looking at one of the most common problems, which is design a URL shortener. So let's get started. So we will touch upon these focus points for this particular problem, which are functional requirements, non-functional requirements, capacity estimation, core entities, database design, API design, high-level design, and then the deep dives. Okay, so let's get started with the functional requirements. Now, for a URL shortener, we only have two core functional requirements. Now, whenever we have to come up with functional requirements in an interview, what we should think is we should think of statements like user should be able to. That's it. And after that, we have to decide what our system is capable of. So, in a URL shortener, a user should be able to submit a long URL and receive a short URL, right? This is the core functionality of a URL shortener, and user should be able to access the original URL using the short URL. Okay, so that's it. We only have two core functional requirements for this particular problem. Okay, now let's take a look at the non-functional requirements. Now, whenever thinking of non-functional requirements, you should have 2-3 points handy, which are: one is gap theorem. One of the points for non-functional requirements can always be a discussion of gap theorem. Others can be low latency, scalability, durability, security, and so on and so forth. So for this problem, let's take a look at the non-functional requirements. So first is, well, the system should ensure the uniqueness for the short codes. Well, obviously, if we are mapping multiple long URLs to the same short code, it would be a major issue, right? So we have to maintain that our short codes are unique. Okay, other than that, for this particular problem, low latency is very much required because redirection should occur as fast as possible. Okay, again, in gap theorem, the p is mandatory for any system which is partition tolerance. So we have to choose between availability and consistency. Now this system, if you talk about URL shortener, it doesn't need to be strongly consistent, and we have to choose availability over here because we would want the redirect to happen as soon as possible. So here we are looking forward for availability, then consistency. Okay, and scalability. So for scalability, you can talk to your interviewer and get the numbers. So right now here we are looking at a system which should be able to scale to support around 1 billion shortened URLs and 100 million daily active users. Okay, so these numbers you can get from your interviewer. Also, in this particular system, there is a huge imbalance between the read and write. So if you think, when we are using a URL shortener, there will be, most of the people would be actually accessing the short codes. Okay, and a very less number of people would be actually creating the short codes. Okay, so that is why here the read to write ratio is heavily skewed. So you can take the ratio as 100:1. Here I have taken it as 1000:1, but you can go with 100:1 as well, so that is also fine. Okay, now let's take a look at the capacity estimation. Now just for a small disclaimer, that if you are finding these words, if you are unaware of these words, if you are unaware of cap theorem and stuff, I would suggest you to go through hellointerview.com's delivery framework. Okay, and the initial few blogs which they have in their structured content. There you will be able to figure out and gain understanding of all these words, and you would understand from where this is coming. Okay, so yeah, let's come back to capacity estimation. So now we were given that we have a daily active users of 100 million. Okay, and read write ratio is also given. Let's say that it is 1000:1. Okay, Peak traffic I am taking it as 100x the average load. You can take it as 10x as well. Okay, I mean these numbers will of course vary. It will depend on your interviewer as well. Okay, your interviewer might also give you certain inputs for these. Okay, so average reads per second, what we are looking at is, so if we have 100 million daily active users and if we assume that each of the user is performing around 5 redirects per day, we will have 500 million redirects per day, which would give us 5000 to 6000 redirects per second. Okay, these calculations are not tough, they are easy. As I said before, go through hellointerview.com's these numbers to know and all these blocks which they have before solving this question. That will make it easier for you. If you need some help there, then please let me know. I can create a video on these capacity estimations separately as well. Okay, now yeah, so since we have taken peak traffic to be 100x the average load, that is why, when we are calculating average read as 5000 to 6000 redirects, peak read traffic could be 100x of these, which is 600k. And average writes, since we have taken 1000:1 ratio, it's coming as 6 writes per second. It could be 60 as well, if you go with 100:1 ratio. And peak write traffic would be 600 to 6000 writes per second, depending on whatever numbers you have taken. Okay, just to be in sync with your interviewer when you are taking these numbers. Okay, now for one particular row we are considering 500 bytes. Okay, now when we say one particular row, so like in db we can store something like the short code, we can store the original url, we can store the creation time, we can store the expiration time and all that stuff. So for original url, we are taking the bytes as 100 bytes. For short code, if we store it in six character length or 7 character length, so based on that, you can take it as 10 bytes, creation time, expiration time. So all of that you can, basically at an average, if you take 500 bytes, it is good enough for this problem. So we are taking 500 bytes per row. Okay, so for 1 billion urls we have 500 GB of data. Again, these calculations are very easy if you have gone through hellointerview.com's numbers to know blog. Yeah, bandwidth and all are not really required. I mean, if your interviewer says you can go through these, but I would suggest not to dive much deep into these numbers and all. Okay, I mean, it's not really required. If your interviewer is pointing you to work on these, then only go through these. And also, at max just go through the average reads and writes and all that stuff. Don't dive much into bandwidth and everything here. Okay, basically we would be wasting unnecessary time over here doing these calculations. So now let's talk about the core entities. So the core entities for a URL shortener, if you have not already guessed, it is original URL, the short URL, and the user. Okay, now database design, again, it is not mandatory that the interviewer would want you to work on the database design, but if they want it all, you can have some tables like these. This is a URL mapping table where we are using short URL, long URL, creation date, expiration date, user ID, click count may be required. There may be questions that if you want to extend this and add an analytics service so that you can analyze how many clicks were there per URL, that way you can use click count. Okay, other than that we can have a user table. Obviously, I don't think this is required for this particular problem statement, because here we are more concerned about the URL shortener, so you can avoid this. So let's get ahead and let's talk about the API design. So now in API design, here we have, so whenever working on API design, simply map your functional requirements to APIs. That's it. We had two functional requirements over here. One was that we submit a long URL and we should be able to receive a short URL. That's it. That's what I have mapped into an API. So we have a post request on URLs. Okay, we are sending the long URL over here, and response is to one created, and we are getting the short URL. Also, what you can do is, rather than sending the short URL, you can simply send the short code, because all of this would be same for your website, right? This would be your domain name, so you can simply send this. The second function requirement was that user should be able to access the original URL using the short URL. So there you can simply do a get on the short code and redirect the user. Okay. Now there is a difference between 302 redirect and 301 redirect. 301 is a permanent redirect and 302 is a temporary redirect. So basically permanent redirect is cached by the browsers. Okay. And sometimes your short code may expire, so you really don't want to give the permanent redirect, so we will be going here with temporary redirect. Also this one is easier because see, browsers will not cache the 302 redirect URLs. Okay, so what happens is you will every time the user will pass through your server, so you can perform analytics and all that. That is why 302 redirect is preferable. Now let's talk about the real deal, the diagrams and stuff. So let's talk about the high level design. Now here we have a very basic flow, very basic, and we will slowly expand this system. Okay, right now we simply have a client, we have a server, and we have a database. So the client sends their post request, get request to the primary server, which will take care of adding that data in the database. That's it. Right now we are not concerned about anything. We are not concerned about how we are generating the short code. This is just how the most basic URL shortener system looks like. Okay. Now let's talk about the deep dives. Okay, so we have already talked about the 301 and 302 redirects. That is why I'm not going through these. Okay. Yeah, so now let's talk about the deep dives. Now, as I said, we haven't talked about how will we come up with the short code, how will we generate the short code. Okay, now to generate a short code, or basically if we have to generate the short code, so let's say we have a URL like, I should zoom in more. Yeah, we have a URL like amazon.com long URL, very long URL. Okay, this is the long URL and we want to generate a shortcode for it. So shortcode would something be like, now this I am assuming is our domain name, okay, bit.ly, and after that we generate a shortcode. Now this shortcode, what should be the length of the shortcode? What should be the length of the shortcode? Now here, as I said, think about the scale of the system. Okay, so it was given that we want to support 1 billion URLs. 1 billion URLs. Okay, so now we have to support 1 billion URLs, and what are the characters supported in our shortcode? Characters supported in shortcode. So we can support capital A, all the uppercase alphabets, the lowercase alphabets 0 to 9. Okay, so how many characters? 26 plus 26, 52 plus 10, 62. So we have to support these 62 characters in the shortcode. Now this is the usual number of characters supported. Okay, you can obviously have a discussion with your interviewer, but 62 is okay. Okay, now we have 62 characters and we have to support 1 billion URLs. So now if the length of the shortcode is 1, how many URLs would you be able to support? 62, right? 62. I mean, if you have done basic permutation combination, if the length of the shortcode is 2, how many shortcodes would you be able to support? 62 raised to the power 2, because we have two options now. So for both options we have 62 choices. So if we keep on doing this for 6 URL, for 6, if you take shortcode, length of shortcode as 6, you can support 62 raised to the power of 6 URLs, which comes out to some 5.x billion. Okay, we only had to support 1 billion URLs. If we take 6 characters, we can support 5.x billion. Okay, 5 point whatever, but we can support more than 5 billion. So we can easily go with 6 characters. Sorry, 6 could be the length of our shortcode. So we are taking the length of the shortcode as 6. Okay, so just keep this in mind. Okay, now, so here let me just write that we have taken shortcode length as 6. Now it should be unique. Now how to ensure that our shortcodes are unique? How to maintain the uniqueness? Approach 1, which is the most easiest approach, and everyone of us can think of, is a random generator, random character generator, a random number generator, something like that. Now a random number generator can of course fulfill the use case here. It can of course generate shortcodes, but how unique would it be? I mean, if you go for 1 billion URLs, you will keep on hitting the same numbers again and again. The probability of collision increases. Collision probability is too high. Okay, also here what you would have to do is generate a shortcode, check in DB, if not present, use it, if present, regenerate. Now this regenerate can also happen 3 to 5 times or even more. It can happen around 10 times as well when we are talking of 1 billion URLs. Okay, so this is a bad approach. Okay, I mean, this would work for small scale systems. What is a better approach? A better approach could be to use hashing. We can hash the original URL, base 62 encoded, and then take the first 6 characters. Okay, so this is another approach. But even with hashing, our collision is not resolved completely. I mean, it's not completely resolved. The collision probability is little lesser, but it's still there. So it's little less, but still there, which means here as well, once you are done with these steps and you have the shortcode, you will have to check in the DB. If it is not present, only then you can use it. If it's present, you will have to reuse. Here also you will have to regenerate it. So here also you have to employ or deploy that retry mechanism. Okay, what is the third approach to solve this problem? A third approach is to have an incremental counter. Now what does this mean? This means that let's say counter starts from 1 lakh. Okay, so what we say is user 1 comes, first customer of our website. So for the first customer, what we do is we have 1 lakh, right? We will base 62 encode 1 lakh. Okay, 1 lakh, and then take first 6 characters, and that becomes the shortcode, which means when user 2 comes, we will have 1 lakh 1. Now with this, we guarantee no collision, which means this checking in DB, we have removed it. Okay, this checking in DB would have some latency, right? You are going to the DB and you're checking, so there would be a network round trip cost to it. Okay, so we have removed that entirely when we say that we can use a incremental counter. Okay, so these are the basics. Let's just go through our notes and see if we have forgotten something. So yeah, approach 1, which is not recommended, is using a random number generator because collisions are possible and we need DB lookup. Okay, second is to use a hash function like MD5 or SHA-256. Okay, now here also the issue is collision. Okay, and it still needs DB uniqueness constraint and retries. Okay, so now what is the best approach? The best approach was to increment a counter for each new URL. So we maintain a global counter, we increment it, and we encode it and get the shortcode. Okay, here we are guaranteeing the uniqueness, and it is extremely efficient because you know what you have to encode. Okay, so it's O of 1 operation. Okay, so it scales well. Now what are the cons? Nothing comes easy. If you have come up with such a good solution, there are some cons to this as well. So if we have one single counter, okay, right now we haven't talked about scalability. We have to support 1 billion URLs. It cannot be supported in one single server. We will have multiple servers, which means we are in a distributed environment. If we are in a distributed environment and we have to support 1 billion URLs and there is only one single counter, which means if we have 5 servers, all need to have same value of the counter, right? All of them will have to have the same value of counter. Now how can we do that? We can have a separate counter service. Okay, so which means counter can be a separate server, which is good. We are saying that okay, we will have a separate server where we will maintain this counter. But now let's say when server 1 is talking to the, let's say a user 1 comes to server 1, okay, and they want to generate a shortcode. So server 1 goes to counter service, server 1 to counter service, okay, and counter service gets busy, right? At the same point, user 2 goes to server 2, the same stuff happens, shortcode, server 2 to counter service, but now it is blocked. Why? Because so when we implement the counter service, obviously we have to make sure that only one server can access it at a particular time. Okay, for that we can use Redis. You can read about Redis. So Redis is single threaded and it will ensure that only one particular server is reading its data and incrementing it. Okay, now this service is blocked. This server is unnecessarily blocked. And similarly, when we are saying, when we are talking of peak write, I think it was 5,000 to 6,000 writes per second. So many users can be blocked at a particular time, right? So how to solve this? So we can solve this by, what we can do is, let's say what we can do is, in the counter service, right now the issue is that every server has to go to the counter service to get a particular number, and then the encoding and all that will happen here in the server 1 itself. So what we can do is, let's say that in the counter service we do not provide single integers. What it does is it will give a batch of IDs to a particular server. So let's say user 1 comes and server 1 comes. Server 1 talks to counter service. Counter service returns, let's say counter service says to server 1 that okay, you can use 1 lakh to 5 lakh. All these IDs are for you to use. Now this 1 lakh to 5 lakh will be stored in server 1. Now server 1 will not continuously keep on going to counter service for every user. Okay, server 1 has received whatever 4 lakh, whatever these number of IDs it has received, and it can use all of these IDs. So server 1 will use all these IDs. Similarly, when server 2 goes, it will get a different batch. It will get something like 5 lakh 1 to 10 lakh, and so on and so forth for the other servers. So here we have delegated. Now what happens is counter service is only giving this number, and internally the servers will maintain and use one of these IDs, and then move to the second ID. Now here what could go wrong is, let's say one of the server goes down. At that point we don't have any idea, or we don't have any any counter that how many IDs did it use. So now here again you can add some mechanism to keep a track of what counter, of what number, or of what IDs they are using. Or what you could do is simply avoid. Why? Because we have taken 6 characters which can support 5 billion numbers, 5 billion shortcodes, and we only have to support 1 billion shortcodes. So we can easily let go of these small batches. If we are missing out, we don't have to deploy separate mechanism for these and make our system tough. So that is the basic implementation. We will also go through our notes and check if we have forgotten something. So yeah, when we have to maintain incremental counter, we can either implement Redis, or we can implement sharded counters plus range allocation. Okay, again now general approach to collision handling. Now this can be a follow-up in an interview, right? So that is why if if you are getting some collisions, general approach is always to enforce DB unique constraint on the short code column. This is very important. And on collision, you will have to implement a retry mechanism. Okay. So yeah. Now I'm not going through the diagrams. For the diagrams, you have the hellointerview.com. You can check out their diagram. Otherwise, let me see if I have it. I can showcase it here. This is another question. Yeah, URL Shortener. So here, okay, we will go through this diagram at the end of our discussion. Okay. Now how to use Redis for the counter based approach. See, Redis is single threaded and supports atomic operations, so you can use it. In a distributed environment, maintaining a single global counter can be challenging. Okay, so what you can do is you can so yeah, we are talking about scaling Redis over here. Okay, let's just go through this. These are not very much required. We will come back to this. I just want to show that particular. Yeah. Yes. So here what we are doing is we are doing counter batching. Okay, so each write service request a batch of counter values from the Redis instance. Example, so for example here we have taken 100 values, sorry 1000 values. You can also take lakhs of values at a particular time, and the Redis instance will atomically increment the counter by 1000. Okay, and returns the start of the batch. The write service will then use those 1000 values locally without needing to contact Redis. Okay, so this is what we were talking about there. Now let's come back to the second part over here, which is how to ensure redirects are fast. How to ensure the redirects are fast, because we also talked about low latency, right? Remember, in the non-functional requirements. So one of the things is indexing. We should implement DB indexing on the short code column. So index the short code column. The other approach and the most common approach would be to implement caching. Okay, so we can have an in-memory cache like Redis or memcached, which will store the most frequently used short code to original URL mappings. Okay, so this is the so we can implement caching, to maintain scalability and to maintain the low latency. Okay, so one is caching, one is indexing, and second is using an in-memory cache. Okay, so just these are just good to know stuff, that memory access time is 100 nanoseconds, SSD access time is 0.1 milliseconds. It's not really required, but it's good to know, and you will sound smarter in an interview maybe. So yeah, that is it, I think. Other than that, how can we scale to support 1 billion shortened URLs and 100 million daily active users? Yeah, so here we are looking at the size of our database. So for one particular row, we are calculating around 200 bytes. We are averaging up to 500 bytes, and taking a look at our 1 billion URLs, we are coming at 500 GB of data. This we did earlier in the capacity estimation. So what database technology should we use? Most will work here. Most of the databases can support 500 GB of data. Okay, so you are not really concerned about that here. Other than that, you should be aware of what database replication is, what database backup is, and all of that. Okay, how to scale the primary server. So now if you have seen here that we have separate read service and separate write service. Why? Because this is a read heavy system, so we might need multiple instances of the read service, and we might need lesser instances of the write service. That is why we can segregate these tasks into two separate stuff. Okay, write service and read service. So yeah, that is it. I think we have covered most of the stuff. Okay, so let's take a look at the final design. Okay, now I'll also go through the key techniques which we have used here. Now these can be, if you are not aware of, you can read about these later and improve your understanding of this particular question. CDNs, how to calculate average size of a field in a row, PostgreSQL for HLD, MySQL. Like you should have some idea about these, so that if the interviewer asks, you can answer the follow-up questions. How to know the latency numbers, how to know the scalability numbers, how to come up with these numbers. There's a very good blog in hellointerview.com, so you can refer that. Now here I have noted down some references which I used when working on the system. First is Hello Interview. Of course, I love their content, and this content whichever I shared is heavily inspired from Hello Interview. So think of it as a revision if you have already gone through URL Shortener. Okay. Then Ashish Pratap Singh, he also has really nice blogs, and it is a good read if you can go through it. Alex U book, I have the soft copy, so I have the hard copy, so I read it sometimes. Other than that, Code Karle is a very good website, a very good YouTube channel, so you can follow this as well. And few blogs are there. I wouldn't suggest going through them. These four are enough. Even the first, second, and the fourth, these videos are enough. These two blogs and this video, that is also more than enough for this particular question. Okay. So let's go through the design. As I said, so yeah, we have the client, we have the gateway and the load balancer, which will route us to the correct microservice. So you have the write service. Now in the write service, it will generate the short code and save it to the DB. So it will talk to the counter or the Redis. Okay. Now here we can have multiple instances of write service. So you can add multiple boxes for the same. Okay. And it talks to the database. We have a read service which will look up the original URL and return the redirect, and the read service talks to a cache. Okay, this is done to to make the system scalable and to make the system make the redirects low latency. Okay, so here we have a cache where we are storing short code and the original URL as key value pair. This analytics service, we have not talked about it. Okay, we haven't noted down also it in our functional requirements. This could be a service like if you want to maintain the click count, from which region you are getting the most traffic and all of that meta stuff. If required, we can have another analytics service implemented. For this question right now, I'm not concerned about that. So this is the design. Okay, so yeah, that is it. Think of it as a revision. Okay, because I know I have not gone deep, I have not dived deep into these content, because it's better if you read it yourselves, but it's also better if you listen to these things continuously, because that is what I think is very important in high level design. Revision, these concepts should be on our fingertips. These numbers, some of these numbers are very important. We should be knowing how long network round trip takes. Okay, it is around 5 milliseconds to 10 milliseconds. So all of those numbers should be in our fingertips. So that is why think of it as a revision video. So if you have already gone through this question, you can use this video to revise. Otherwise, if you are just listening to this video for the first time, and if you haven't solved any URL shortener question or any high level design question earlier, this might seem tough to you. So yeah, if you found this useful, you can drop a comment with the next system you would like me to cover. Yeah, other than that, if you have any feedback for this particular video, just let me know in the comment section, and I'll try to implement that. Also, if you need these notes or anything, just let me know anything, all of these in the comment section. So yeah, thank you for watching.